everyone. So today we're going to be continuing chapter 16, section 2, the electric force. Now we're going to use these degrees to find the components, okay? To find the components of the x and y components of each force acting on Q1. So we're going to copy all of these because we need all of these values. So now F21, F1x, we have to find F1x and F1y. F1x is basically the magnitude of F21, which is 7.2. And for x, you use cosine and then the angle, which is 0. Here for y, you use sine and the angle is 0 again. And if you find them, use the calculator, you will get this as 7.2 and this as 0. Now for F31, F1x or F2x, sorry, and F2y. And the magnitude is 2.88. Then cosine for x and sine for y, and the angle is 270. Okay, 270. And you will get this as 0 and this as 2.88 newtons. Okay. Finally, for F41, so F3x and F3y will be equal to the magnitude, which is 5.4. Then for x is cosine, here sine. Then the angle is 315. And when you use your calculator, you will get 3.82 and negative 3.82 newtons. Okay, now we have to find the x and y of f or f naught, okay, which will basically be, you have to find the sum of all of the x values and all of the y values. So here f1x plus f2x plus f3x and f1y plus f2y plus f3y. Okay, and for f of x you will get, for fx you will get 11.02 newtons, and for fy you will get negative 6.7 newtons. Okay, now you want to find the magnitude. Okay, so we found fx and fy. Now you want to find the magnitude and the direction. So for the magnitude, we will use the Pythagoras or the Pythagorean theorem. Okay, which is, so for the magnitude, we will use f squared is equal to fx squared plus fy squared. Okay, which will be the square root of f of x squared, fx squared plus fy squared, and you will get 13 newtons. Okay, now for the direction, you will use tan. Okay, tan theta f of y over f of x, or opposites over adjacents, because if you see here, this is y, okay, this is y and this is x. So this is y and this is x. Okay, let's say we want to find this angle, this is theta. So f of y is the opposite and f of x is the adjacent. This is why it is fy over fx. Okay, and when you substitute, so negative 6.7 over 11.02, you will get theta is equal to shift tan negative 6.7 over 11.02. Okay, and your answer will be negative 31.3 degrees below the x-axis. Okay, so now let us talk about equilibrium. Okay, equilibrium is basically an object that is in equilibrium. Means that the net force acting on this object is equal to 0. So equilibrium basically means that F net is equal to 0. Okay, this is according to Newton's first law. And the equilibrium position of a charge is the location at which the net electric force on the charge is 0. Okay, so let us now do a question. Let us do a question that has to do with this concept. So here they say a charge Q1 of negative 5 times 10 to the power of negative 9 C, and a charge Q2 of negative 2 times 10 to the power of negative 9 C are separated by a distance of 40.0 centimeters. Find the equilibrium position for the third charge of 15.0 times 10 to the power of negative 9 coulombs. So here let us sketch what they are saying. So here we have a line, and here we have Q1, and here we have Q2. Okay, here Q2 is negative and Q1 is also negative, and we have to find the position of point Q. So what we're going to do is basically take this distance as x and this distance as 0.4 minus x. Why did we do that? Because we know that the distance between Q1 and Q2, it is 40 centimeters or 0.4 meters. So if this is x, this distance is x, this means that this distance is what is left from 0.4. Okay, so 0.4 minus x. So now we know that when f naught is equal to 0, so here let us say f1 minus f2 is equal to 0. Okay, when you take one of them to the other side, basically means that f1 is equal to f2. Think of it. You cannot have a state of equilibrium if the electric forces aren't equal to each other. Okay, because when they're equal to each other, they will basically just cancel each other out, and resulting in F naught being 0 newtons. So now that means that we know that F is equal to K Q1 over R squared, right? So basically what we're going to do is write this formula equal to the formula for F2. So F1 is Q1 over R squared, which is equal to Q1 Q2 over R squared. Now R squared here is represented by x and 0.4 minus x. So we're going to erase this and write for Q1, because here the distance between Q and Q1 is x. So we're going to write x in this case here. and here 0.4 minus x, and each of them squared, of course. Okay, so now what is common between these? KQ. So you can just cancel KQ in both out, okay? You will be left off with Q1 over x squared is equal to Q2 over 0.4 minus x squared. Okay, so now what you're basically going to do is get rid of the squared, which we will use the square root in order to get rid of them, and you will be left off with radical q1 over x and radical q2 over 0.4 minus x. Now you just cross multiply and you will get x q2 equals 0.4 q1 minus x times radical q1. You take this to the other side, which will become x radical q2 plus x radical q1 equals 0.4 radical q1. And then you find the greatest common factor here, which is x. So you take x outside, radical q2 plus radical q1 equals 0.4 radical q1. And then you take this to the other side. So you will write x equals 0.4 radical q1 over q2 radical q2 plus radical q1. Okay, and when you substitute the values, you will get x is equal to 0.25 meters. So what does this mean? It means that the distance between q1 and q is 0.25 meters, and in order if they ask you to find the distance between this point from q1 and q2, you can also just basically subtract 0.4 minus x, which is 0.25, in order to find it. So this is the distance between q1 and q and 0.4 minus 0.25, which is equal to 0.15 meters, is the distance between Q2 and Q. Okay? So this was it for this video. I hope you understood what I covered. If you have any questions, don't be afraid to leave them in the comment section down below, or email me at educology.help@gmail.com. I left some notes about this lesson in the description box down below, so if you would like to, you can check that out. Thank you for watching and hope you have a good day.